You have of innovation, new technologies, and that's going to trigger more technology, and that's going to trigger more technology, especially when they can make money and more innovation. So we have these kind of quick little factors. Didn't go into great detail of them, or kind of building on previous ones. And then this technological innovations would explode in the second industrial revolution, just like they exploded in the first industrial revolution. Now, I put a quote in there by Newton. You don't need to know the quote, but Newton, when he wrote Principia Mathematica and invented calculus and invented gravity, before Newton, people just would fly off into space. But now Newton made sure that you stayed put and the planets didn't topple off into the sun. But he was building on other brilliant works, especially like Johannes Kepler. Well, just like this, innovation, new technology breeds new technology. They build on previous technology. I mean, the big one is, think of all the innovation that's going to come out of electricity. It wasn't that they were smart, but if you didn't have a power source, you're not going to make these innovations. So build on previous innovation. So what is it? Before, steel was incredibly difficult. You had to superheat iron, melt, impurities would kind of bubble off, add a couple of things like cadmium and nickel, and you got something stronger than steel, but it was incredibly difficult. But when they started making new iron production methods to make stronger iron, that would lead directly to a process called the Bessemer process. And then eventually that would be improved to the open hearth process to make steel. And steel production would be the symbol of the second industrial revolution. That became the measure of the power of your country, how much steel you could make. The Bessemer process right here, superheating these vats of iron that would, you could basically melt out or get out all the imperfections, would lead to the huge open hearth, these huge vats of iron that would be superheated up to 1,000 degrees. I can't even begin to tell you how dangerous these places would be to work. And steel production would explode. And steel would change everything. Steel is stronger and lighter than iron. And so you could have much more advanced construction. So think about buildings in general, like bridges, everything would become significantly safer, build faster. And places that had coal for the fuel, and then iron and the other mineral or other elements needed would become steel making headquarters. Anybody know what town that is? That you could never see the sun by 1900. And everything every breath would be gritty with the pollutants in the air. And yes, every child had asthma. Good guess, but no. The Steel City. It's literally, there was just steel, just soot everywhere from this production. Andrew Carnegie knew nothing about steel. But after the Civil War, and he got rich in arms contracts during the war, he bought the Bessemer process before anybody else in the U.S. So even though the U.S. was behind Britain, soon the U.S. steel producers, Carnegie alone, would produce more than Britain. And eventually, Carnegie alone would produce more steel than Britain by the end of the 1890s. Carnegie's company. So iron and steel production would become the measure of economic growth. So purple, iron, look at 1880. Look at 1900. And that's steel. American steel. Literally, they would measure how much steel a country produced, and that would be their power. By 1900, American companies produced more steel than the rest of the world combined. So remember I gave you trick yesterday? Textiles, railroads, iron, and coal. Well, let's do the second industrial revolution. Railroads again. What's a new power source? It's not coal still being used, but what's that? Oil. S, steel, electricity, chemicals. Once you have petroleum, you get the chemical industry. Virtually the entire chemical industry today comes from petroleum. If you're buying petroleum, you get all this goop of chemicals, and that's where the chemical industry started. And it's still basically there. plastics, paint, aspirin, Advil, artificial coloring, all petroleum. Yes. I can't. Trick and Wilson. Trick is textiles, railroads, iron, and coal. Textiles, railroads, iron, and coal. This, railroads, oil, steel, electricity, chemicals. Chemical will be big business. Railroads, oil, steel, electricity, and chemicals. We're all about the chemicals. The US would be one of the leaders, like companies like DuPont, paint would be a big one, but Germany would really, the new country of Germany. So, next one. There's not a particular order. I just kind of put this down like, wow, this is impactful. Refrigerated cars were a big deal. Okay, refrigeration had been invented in Louisiana 50 or 60 years before, but by the 1890s, you start getting refrigerated railway cars. And they became more and more advanced really quickly because there was a financial incentive. Gustavus Swift, Joseph Farmer, Swift. Now, Swift did not invent it, but his company, that was a meat packing company, invested in the refrigerated cars. And then Armour, well, you can see the big packing plants for Armour. This would change the entire way that people ate, consume food. Not only that, their relationship with food changed. Refrigerated cars would lead to a trigger, a series of events that would change the entire food consumption of food. You see it in Britain first, but the United States. And I'm not exaggerating, I'm probably understating. Changed everything. It was such a big deal. That's why this industrial revolution was a change that we came to comprehend. So, yeah, this food production on a massive scale. Meat packing industry would explode. Meat packing, I mean literally packing the meat so you could ship and sell. Before refrigerated cars, every town had local slaughterhouses and they would be gone. I mean, every town there'd be 3 or 4 slaughterhouses. And animals would be taken there right in the middle of town, usually by whatever waterway, by some kind of creek or river, there would be a slaughterhouse. If not, they would just dump it in some kind of slough under. And they would kill the animals right there. And so you would have this right in the middle of the town. So you would have this, I mean, this area where you could hear the screams of the animal before they're slaughtered. You could smell the blood, the manure. Yeah, it's right there. It's right there with blood, right there. You go walk by it all the time. You go by the nearest riverway and just dump all the refuge, the offal that's hauled. And they just dump in the water. And stuff goes on right in front of you. And you literally go there and you can buy some, especially like families without a lot of money would send their kids to go get like little bits from slaughterhouses in the stomach and all that. We're fucking blood. They would use that because you need protein. I know it sounds awful. I'm just telling you, that was life. It's right there. So even if you didn't actually kill and slaughter them, you couldn't escape. Now those slaughterhouses are all there. Now, let's rephrase it. It did not overnight. Refrigerated cars no more were slaughterhouses. It took 80 years, but they would all go away. One by one disappear. And so think about it for a second. The production of food, especially meat, in these billions of animals that are killed for our consumption, it just goes away. You don't see it. You just also buy this kind of meat stuff. You hold it where they sell it. I'm kidding. And that's production. You're not separate. You don't see the blood. You don't hear it. That really does change your relationship. And don't get me wrong, it's not a pleasant thing. But at the same time, by distancing that, it makes it easier to just allow the slaughter and not care about how the animals are treated. And yes, I eat meat and buy it. I know. Second period, somebody was having a little snack and had a piece of like meat or out of the gas station. They have no connection with it. And it says 100% beef. Hey, define beef. It's something from a cow, and I'll leave that as something. Hamburgers, same thing, hot dog. I mean, we're hoping for the best. But we don't have that connection. And then, who replaced them? What happened to small producers of food then? They're gone. We had to have a local slaughterhouse because the animals had to be killed, slaughtered, and eaten right away or they spoil. especially beef. Refrigerated cars allowed for the mass production of beef. It totally changed the way people ate because beef had to be slaughtered because it spoiled so fast. But now it would last longer because of refrigeration. And they would discover how people like to eat beef. Because you don't have as much a threat of spoilage, they could spoil the beef a little bit. Let it sit out and spoil once a little bit, and people like that. You buy beef, it's a little bit spoiled. It has a taste of it. Prefer, for whatever reason, we as a society, you like beef. But all of that was discovered. And so it totally changed everything. And so we have these massive production instead of little places, huge. And then they ship all the animals to one spot and you have consolidation. Many companies became just a few, and now it is literally just a few. And we soon start getting monopolies of food producers, or at least things that acted like a monopoly. So here's Armour that became big in the canning and also the selling of frozen food. So they take various meat products and they expand. Expand's coming, yay. But it shows their worldwide production, our supply chain. So here it goes cattle and sheep from Montana, put on a train and sent to one spot. No longer does it have to be in a localized production. It goes to one spot. And where was most of the production? Who would become the hog packer, the meat producer of the world? Chicago. Miles of stockyards. Animals would be coming. That's terrified animals coming in. And you could smell Chicago for miles. 1 million people by 1900, and that smell would be everywhere. Hey, what's the smoke? It would burn the stuff they couldn't use. Or boil it to render out the fat, render out other things that you use. And there's nothing, I can think of nothing that smells worse than a render. Nothing. It's hard for me to comprehend. And yes, there's a lot of really bad smells. I'm counting it. So for example, in October, I went down to Denver. My wife and I went down to Denver to go to a concert. We flew in and we drove right by the arena. Food, pet food factory in Denver. It's right along the route. We went to my sister-in-law's house. And they rendered, you could smell it about 6 blocks of it. People talk about the Farina factory all the time. This is like, I've been to part of town, so this whole section of town that just reeks. That was Chicago. The smell, I guess, must have been unreal. They would talk about it, couldn't escape. Manure, blood, death, rendering. Chicago. Kansas City would be kind of like a secondary one. Why? All the railroads went there. And so all food production changed. To give you an idea of the change. So every day you would have to buy meat if you could get that protein. And every day you would go to a local market and get what you need. Every day. Refrigeration began to change them. All the little local markets, what happened to all of them over the next 80 years? Corner grocers, gone. All these little grocers in town. In Helena, that when Helena first started, if you go to the areas, especially just west or east of downtown, you go to these residential areas and there'll be these strange square buildings that don't really fit in with the rest of the houses. Those were corner groceries. Every little town had a little market. You had to buy food every day. I'll say you don't have to buy food every day. And these little markets, these little stores, driven out of business, couldn't compete. They became bigger grocery stores and then eventually supermarkets. Corner groceries to bigger grocery stores like the Piggly Wiggly, which is so big in the South, a big grocery store. And then one of the biggest, the first really big grocery store monopolies, the A&P. And all the other stores disappeared. So let's review terms. What is the iron rule of economics? It's therefore it's the iron rule of life. Got big companies, the big always have a competitive advantage because they have lower costs because they can be more efficient. Economies of scale. Once you have refrigerated cars, it accelerated economies of scale. So yeah, you might think this is good, but it also could be really bad if you want to start a small business, you try to compete with it. Let's get to another innovation, Alexander Graham Bell. Alexander Graham Bell, what did he invent? The telephone. He used 8 different inventions to come up with a telephone. That's a classic example of standing on the shoulders of greatness. Now, he's trying to come up with something that would help the deaf, but invented the telephone. Now, the big problem with the telephone is you would talk into this and have a little membrane. It would shake the membrane, and electrical receptors would pick up that and send it down the line. And at the end, it would shoot out the electrodes and move this little membrane, and that he worked it out where you could hear the voice. The problem was he didn't have an amplifier, so it really didn't work very well. It would take about 20 years until Thomas Edison's lab came up with an amp. You shoot the electrodes first through charcoal, and not just charcoal. And then that amplifies it until you get to the membrane shape. And so they still use some of the best speakers for stereos, still have charcoal. If you look at an older one, they shoot through charcoal and then it amplifies the sound. You rip apart an old one. Now it's been digitized, it's a little bit different, but a lot still use charcoal. He just literally just ran electricity through everything until something worked. Just tried everything. So that's Alexander Graham Bell. And think about what this would change. By 1890s, when you have telephones, think how this would change news, direct communication, but think about what this would do for business. It would be much easier to get commodity values, price values, order sales, control companies. It allowed for bigger companies, which remember that we'll get to. Next, Christopher Sholes and the typewriter. Another innovation, and steel would be really important for the typewriter by the end of the century because iron was so heavy and difficult to use. The first one was a manual typewriter, and every time you would push down a button, you have to push it down pretty hard. And the first one had a little, it would rotate to the letter you wanted, and then basically push it into a tiny little membrane with ink, and that would make an imprintable letter. That would be the first mechanical typewriter. Eventually perfected to something that worked a little bit better. You push this down, and a little hammer with the letter would come up and go through that little membrane with ink, give you the letter. Does anyone play with a mechanical typewriter? Yeah, I first tried to learn how to type with that. It's hard. And then I learned with the electric typewriter, which was seen as such a technological advancement, which it was. And it's amazing how now it's just like, what's an electric typewriter? That people kind of collect with, When I first started teaching, there was a whole room, closet full of 100 electric typewriters, because they're already becoming obsolete. But he invented the keyboard, Sholes did, that everybody copies to this day. We call it a keyboard today. It was not called a keyboard then. Why did he invent a keyboard like this that we still use today? Yeah. Yeah. And either alphabetical, but the big thing was if you're typing, obviously your index fingers move faster. This moves slower. If you put the letters you use the most right here, see these little hammers? They would be right next to each other, and if you go fast, they would catch. If you ever played with an old mechanical typewriter, if you put a bunch of keys down there, yeah, I would play and do that. It was fun for minutes, but so you had to slow it down. So vowels over here, period right there, and you type slow. But that's how everyone learned how to type. So when they started, you first see the first computer keyboards in the late 1980s for mass use. They taught the same way to type because that's how everyone learned. That's what was stopping. There's no reason for that today, but that's what we have. Think how this would revolutionize printing. Just revolutionize it. Much faster to type than to set every single letter on a printing press. You can type it and then use that as your, basically put it on a piece of metal and use that as your printing press. Next, another big one, once in no particular order, this might be the most important, but I put it here, the electric dynamo. So Michael Faraday, he's an Englishman, and he's working with magnets. He thought magnets would be a source of power. And he realized something: electricity. And they had electric batteries. You put zinc and nickel and cadmium together and make this kind of bubbling little cauldron. Drop iron in it, and that would give you electricity for a while. A battery. So they have small little bits of battery. What he thought was that, well, he thought he could use magnets as a way, big magnets, to like push like railway cars back and forth, like magnetic through tubes. That's what he thought. That's what he's working. But anyways, back to this. If you use a magnet and run the electricity through a cord, it creates electricity. Run electricity through a steel wire. And he dropped a bunch of iron filings. Subtracted. And oh, that's great. And then he had a eureka moment. If electricity creates magnetism, well, magnets create electricity. So what he did is, here's his original schematic. There's him right there playing with a magnet, that's for the battery. But here's an easier one to see. Put a magnet right here. Surround it with an iron core connected to wires. And then you turn the magnet. This first one's literally a crank. And you turn it, and it's electricity. Now, it's going to take 50 years. I mean, great, you create electricity. You got nothing to use it for. You got electricity. Hey, that's what shockers. But I think you can see where this is going. The electric dynamo provides most of the electricity that people use to see. His invention would change everything. So once you have this, you find a power source to turn the magnet. You get bigger and bigger and bigger and bigger. Heck, go out to Canyon Ferry. What does Canyon Ferry have? 6 massive dynamos that the water goes through and turns the wheel that turns the magnet. Big magnet in the middle. That's what it is. That's all electricity is. A brilliant device. What's a windmill? The wind turns a little magnet. That's what it is. They tried that with solar power first, try to convert sun's energy into boiled water and steam to turn the magnet. Didn't work. Eventually, they would come up with a different way, which we might get to when we get to the 1990s. So now we have some electricity, more and more, because it turns out to be really efficient while the sun, solar energy. So immediately, once they discovered uses for this, I mean, you can just see it building up, exploding in the 1880s. How do you get the electricity to where you want to use it? Now, the easiest basic way was called direct current, or DC. There's another method called AC, or electric alternating current. Thomas Edison's lab, there he is holding a light bulb. He was electric. He could just hold a light bulb in a power. Because he used electricity so much in the light, he just had current running through it. And so he touched it, shocking. But I made up. That's 100% not true. But please tell people that your science teacher told you that was true. Everybody tell me. Right? Mr. Caffrey said. Sure. Philip said. Make sure you say it, right? Edison invested his new company, eventually called General Electric, into direct current. Nicholas Tesla came up with a better, an immigrant to the United States, like I said, immigrants incredibly innovative. He came up with alternating current, which is much more efficient. Now, let me explain it the best I can. The best I can very quickly. So, direct current, you have the power source. Here is the schematic that isn't that good, but I put it up here anyways. The power source, and you shoot it down one line to what you're using. Power source, direct line to what you're powering. Power source to the light. This is what batteries do. The problem with direct current is it's a direct electrical current. It bleeds out of the wire, so it's relatively inefficient. So when it bleeds out, that means the further the wire goes away from the power source, the less electricity you get. So Edison's idea was his company would sell little tiny electric dynamos to every household. Then they could power through a direct current. That was his idea. Alternating current is this. Okay, if it bleeds out with one, let's just use little bolts of power. instead of one line, we'll have a loop. Power will come through and come back. So it just loops. So you shoot one little bit of power this way down the loop. And then shoot another one back the other way. Here. You get that back and forth, alternate back, fast. So it's imperceptible, and it goes at speed of light. So to whatever you're powering, it's basically one continuous power source, but it's quick little jolts. That means that it doesn't bleed out as far. So you can have one place produce electricity and go out to many different households or businesses. So here's an extension cord, right? We've all seen an extension cord with a wire. Have you noticed there's two cords? That's the loop. And when you plug it in, it connects the loop and power starts to go through it. Now, there's a problem with this. If it's a loop, that means anything that connects the power source, anything that will connect it, anything that connects electricity, you're part of the loop then. You put steel, copper, people. We can be the loop. You connect the wires to us and power goes through us. I don't even know that. That's bad for you. So for example, have you ever taken a fork and stuck it in an outlet? Fish probably wouldn't be here. Don't do that. See, life lesson. You notice those two prongs? That's the loop. That's the loop. So it's dangerous. And that's how Edison tried to sell it. He said, alternating current might be more efficient because you have one power source, but it will kill you. It will kill you. And how did he prove it? Does anyone know how he proved it in 1898? Huh? So, Topsy the elephant was condemned for murder. I'm not making that up. Topsy the elephant killed a handler, a circus elephant. And they literally, I'm not kidding, they had a trial for Topsy. And Topsy was condemned to be killed. True story. They condemned Topsy. And Edison said, I'll kill him and show you how dangerous alternating current is. So that's Topsy right there being led to the electric chair, so to speak. Which is, I got to be clear, torturing an animal to death. Electric chair was torture. It's off. It took about a half hour for Topsy. I want you to ponder this for just 1 second. I want you to ponder this. They had a trial for an elephant. And then they condemned the elephant to die. Just think about this for a second. Think about the logic. Hey, what's the only way to stop elephant rebellion? You got to get tough on it. I can't even wrap my mind around it. And then someone said, and you know how we should resolve this? So we capture this elephant, but you can't really domesticate it. You capture it. Yanked it away, tortured it till it did what we wanted, and then we'll torture it to death. That's logic. So that's, and you notice the headline, elephant electrocuted for murder. But here's the thing. Yes, that's true. But the direct dynamo, how do you power the dynamo in each house? Do you see all the problems with this? How do you do this? And so it didn't take hold. So they murdered the elephant for nothing. George Westinghouse would steal Tesla's idea and come up with the alternating system. And that's his dynamo. That's the dynamo. Right in the middle is the magnet. Here's the steel cable, and they would spin this, spin it. You can see the crank to turn the magnet. You can see it right there. So you use coal power, coal. Basically what they do with the coal, superheat steam. They run the steam through a series of pipes so it moves very fast and turns to the dynamo. Or you can see it all the way to every other power source. So almost all of Northwestern Energy's power comes from electric dynamos, almost all of it. I should add, Northwestern Energy has already committed to two different AI companies, more power than they actually produce for the entire state of Montana. And to two companies. I think the companies will fly by night. But what does that mean for the cost of electricity in about 3 years? Double. They've already gone up about 50% in the last 3 years. Okay. Anyways, let's get to Edison very quickly. Just write down Edison. Edison had a lab at Menlo Park, New Jersey. And what Edison did, he hired a bunch of tinkerers. He was a tinkerer too. He was very creative, but they worked for him. So every invention that they made, who got the credit? Edison got it all. So we're actually not sure what Edison did and what he didn't do. He did some, but most of it was invented by other people. That's how virtually all invention happens today. Most people work for a corporation and they sell everything they do to the corporation and they get the profit. So Edison right here, and there he is holding a light bulb. You see the light bulb's on. Like I told you, the electricity just funneled through him. So tomorrow we'll pick up with Edison and then get to other. I'm not kidding. If you don't have questions, I don't have answers. I need a question to answer for the review. Would you like a reading assignment? The last one of the semester. It'll be due on Tuesday, 771 to 795. The last. I know we got the semester test, but school still goes on for your dining and dancing entertainment. Lexi, I like your, you have this kind of this drawn, like just the line, just the basic outline. Very good. Goodbye, everybody. Right when you find work,